Let's talk about equivalent expressions. So here we see I have a given expression, 2x plus 4 times the sum of x and 1 plus 8. First thing is, how can I simplify this expression? Simplest form refers to using the distributive property and combining like terms to get it into its simplest form. So if I use the distributive property here, I'm going to multiply 4 times x and 4 times 1. So 2x plus 4 times x plus 4 times 1. And then I have the plus 8 at the end that I can bring down. So my first step to simplify was to use the distributive property. Now I can combine terms that are alike. 2x plus 4x is 6x, plus 4 plus 8 is plus 12. So simplest form would be 6x plus 12. And I cannot move any further to simplify because 6x represents multiplication and we're not using a value of x right now. Multiplication comes before addition. So if I don't know what x is, then I can't do anything to 6x plus 12 because I don't know what value I'm substituting for x. It's not an equation where it has an equal sign. It's just an expression. So 6x plus 12 is as far as we can go, so that would be considered simplest form. Lots of options to write a different but equivalent expression. We could apply the distributive property. So 6x and 12 have a common factor, a greatest common factor of 6. So if I factor that out, I would be left with 6 parentheses x plus 2. So that would be an equivalent expression to the given expression. There are other ways to write equivalent expressions using commutative and associative properties and such, but since this unit has used a lot of distributive property, I'm just going to use the distributive property to write 6 parentheses x plus 2. So now we have 3 expressions here. We have the given, we have the simplest form, and then we have the new expression that we came up with that we think is equivalent. Let's prove, we're going to prove that all 3 of these expressions are equivalent by choosing a number and substituting that number for x. They're equivalent if any number we choose produces the same value. That would prove that they're equivalent. So we can choose any number we want and it should produce the same value. So let's use the number 5. If x equals 5. So to prove that they're equivalent, I would have to go back to each one of my expressions from the beginning and substitute 5 for x. So 2 times 5 plus 4 times 5 plus 1 plus 8. That's what my first step would look like to show that I'm substituting 5 for x. And now I would use the order of operations to simplify. Parentheses first, 5 plus 1 is 6. Now we have multiplication. 2 times 5 is 10. 4 times 6 is 24. And now we add from left to right. 10 plus 24 is 34. 34 plus 8 is 42. So in my given expression, when x equals 5, the value is 42. I should get the same answer when I substitute into the other two expressions. So let's try it in the simplest form. So we have 6x plus 12. So if we substitute 5, 6 times 5 plus 12. Multiplication comes before addition. So 30 plus 12, and 30 plus 12 is 42. So we can conclude that the given expression in the simplest form are equivalent. Now let's try the last expression. 6 times 5 plus 2. We're going to use order of operations since we're substituting. 5 plus 2 is 7. 7 times 6 is 42. So we have used a value for x to prove that our three expressions are equivalent.